So I just have to put it into my calculator.
I love that.
Yeah.
Put the second one in your calculator. That's
Okay.
trickier.
So
And you're using the graphical one, is it?
yeah.
So I'll use the simple one. Equals.
So uh, I got um I got that log 5 to get to 61 is 2.55. I'm not sure that's right.
Hang on. So this my calculator. See this L minus R down the bottom, left minus right. I think it is.
Yeah.
So my answer is very far away from 0. It's 13.8. So if I press equals again, now it's at 0. So did you get something like that? 0.888557.
No, it's not.
Did you do log of both sides or something? Did you say?
Yeah, I might have done it wrong. I put in log 5 and then bracket 61.
Sorry, when you said you were going to put it in your calculator, I thought you meant you'd put the whole question in your calculator. I didn't realize you'd try to solve it. So if you're solving it, so I just literally just copy and pasted the whole question in.
Yeah.
So right, we'll try doing it properly. How would you solve the first one?
Would you just do log 3 and then 20?
Oh, I see what you're saying. So yeah. Okay. So you're using that thing. So 3 is the base. So it's log 20 base 3. Is that it?
Yeah.
Okay, and then you put that in your calculator. And then for B, you do log 61. It was base 5, but that's equal to 4x minus 1. Because the power
Yeah.
was 4x minus 1. And then you still have to solve that to make it x equals.
Right.
So how would you go about that?
So could I just put that into my calculator?
You could. How would you solve like 4x minus 1? How would you make it x equals?
By adding 1 and dividing it by 4.
Yeah, so it would be that thing there, plus 1, and then all over 4. Or from the very beginning, you can put it in your calculator. Any questions about that?
No.
So this is so the book uses the method that we did last time, and looking back on it, it kind of makes sense for that one. For this one, if I took logs of both sides, so I did log 5 to the 4x minus 1 equals log 61. So you're doing the same thing to both sides, which is kind of what you're used to doing with equations. Log rules, the power can be multiplied by the log. So that's 4x minus 1 times log 5 equals log 61. How would you solve that?
Would you then just do 4x minus 1 equals to log 61 minus, oh no, divided by log 5?
Yeah.
And then Oh, and then just add 1 and divide it by 4.
Yes. And so I used to just have a default log button. I'm just going to use base 10 as the default. So that's 61. That's over log. I'll just do base 10 again. 5. So then that answer, so we just find that. So to that answer, we would do +1 and then divide it by 4, and we would get the same thing.
Yeah.
So I suppose your initial one would work. You did log 61 base 5, and then don't forget that that's equal to 4x minus 1. And so you'd still have to add 1 and divide by 4. Or even simpler, calculator. Any questions there?
No.
Okay. And we've yes, I did my homework too. I looked up the exam questions for the last topic we did. There was only one past exam question so far in the new spec, and the way they did it was they said a student did this working out, find what the student's mistake was. And so although like 7-mark question, you think, oh, I can just put the whole thing in my calculator, the way they phrase the exam questions is so that you have to know the method to figure out what the student did wrong.
Yeah.
So they did find a way around it, and I imagine they would do something else here. Well, we'll see. Okay, how about this?
Okay. So.
Or 1 second. That's before we do that. Yeah. How would you do? So exam question. How would you do 3A?
Okay, so. Well, I'll just put that into my calculator.
Try it. Yep.
Okay. So. It just takes a bit of time to load. So I got 5.92.
So A is 5.92. 5.9223 sig fig. Try putting B into your calculator.
Okay. So. So I think I've lost the log button on this calculator here.
On the graphical one?
No, on the other one.
Oh, the simple one, is it?
Yeah. Oh, actually, I just found it. Sorry.
Yeah.
So. It gave me x is 3.2.
One ships off. X is 3.2. Oh, not you. Oh, yeah, I have to get out of the habit of switching things. So that's 3.2, and X is 3.2. Great. I just wanted to do some extra practice on that one, and I'm happy. Okay, great. Next one. Okay, how do we do this? Sorry, any questions about those two that we just did? Those all right? Yeah, I think they're okay. Okay, how about this?
Is that just the part where I just put the polynomial thing into my calculator?
Which polynomial thing?
Where you do like 5x squared plus 0x plus 0.
Okay.
And then I got no, it gives me imaginary numbers.
I see what the problem is. So let what be equal to what?
I'm not entirely sure.
So you have 5 to the x here.
Yeah.
So let 5 to the x be equal to, let's call it a. So rewrite this, what would it be?
So let 5x equal to a. So do I need to say something like what? So 5 to the 2x is a squared or something, or
5 to the 2x. How could you write that in terms of 5 to the x?
that's 5 squared times 5 to the x.
Yes. And so that's the same as 5 to the x squared.
Yeah.
And so rewrite this in terms of a.
So does that mean that? So it would be a squared minus 12a plus 20.
Yeah, so it's not 5a squared, it's just a squared. So now try solving that.
Yeah. Okay. I got that a is either, or even actually x is either 10 or 2.
And so are those our answers?
It says giving your answer, so I'm guessing it'll be one of those two.
We weren't asked to find a.
You'll have to find x.
Yep.
So if a is equals to 5 to the power of x,
Yep.
does that mean that I would do 10 equals to 5 to the power of x?
Yeah.
So I can just put this into my calculator, can't I?
Yep.
So I got x is equals to 1.43 or x is equals to 0.43.
One more sig fig on that one.
All right. 0.431.
1. Let us see. 1.43 and 0.431. So basically this is a hidden quadratic, a quadratic in disguise. My instinct would be right from the start to say 5 to the power of 2x minus 12. So literally just a question. Hang on, to the power of x. So just as closely as I can, just copy and paste the question. How do I do equals again? Equals 0. Shift solve. Lucky 7. Oh yes, there we go. So what's the problem?
It only gives you one answer.
Yeah, I only got one answer, and so that's why you have to go about this the quadratic route. Although between you and me, Andrey, shift solve, my initial value, I'm going to do minus 999. Come on, calculator. There we go. So I did one to the very left, and then you can do one to the very right if you recognize it's a quadratic. But those chances. Only I take. Let's see. So yeah, basically it's a quadratic. You let a or some dummy variable be equal to this bit here. The second bit, the lowest power, and then you solve for that, and then you unlet it, so you swap it back and solve. Any questions there?
No.
So that's a hidden quadratic. Let's just find an exam question involving that stuff. Yes. Question 4.
There's my calculator, can't I?
Sketching the graph, yes. How about question 4b?
So is this where I would do, so 4 to the power of x equals to a.
Mm-hmm.
And then equals to a, and then it's just going to be and then it would just be a squared minus 10a plus 16, and then it gives me that a is equals to 8 or 2. And then do I then need to do, so a is equals to 4 to the power of x, or 2 is equals to 4 to the power of x.
Mm-hmm.
And then I got that x is going to be equals to 0.5, or x will be equals to a third.
0.5 or a third?
Yeah.
That doesn't seem right. Oh, sorry, this one's 0.5. Yeah. And then this one a third.
Yeah, it says 0.3 recurring. So
4 to the power of a third. The cube root of 4. Did you do...
I think I might have written it wrong.
Let's try that again.
Yeah, I wrote it wrong, sorry.
Right.
So it's 1.5.
1.5. Okay, great. Look at those numbers. So half or 3 over 2, 1.5. Great. Any questions there?
No.
Okay, let us now go back. How would you do this?
Okay. So I'm guessing just put it into my calculator.
Yep. I'm going to try graphical. It'll probably be too quick for me.
If I have to rotate right, that's a really weird number.
That's all right. It said the 4 decimal places.
So shall I say the answer?
Yeah.
I got minus 74.7788.
Okay. and that is x. Nope.
No, wrong.
So 3 to the x equals 2 to the power of x plus 1, which is still in the power. I got minus 600, and what did this calculator do? It's giving me lots of answers. Go on, you use your calculator, see what you get. Simple calculator. Ooh, I've never seen it like this before.
This
Okay.
is really.
Simple calculator. I know what happened. Did you already delete your answer from your calculator?
No,
You see your L minus R is a 0?
no, it's not.
Press equals again. It'll go blank for another second, and it probably still won't be 0 after that.
So I press equals again because the L minus R still isn't 0.
Yeah. It'll probably be something like something times 10 to the minus something, so it'll be a very small number, but it has to get close to 0. Sorry, it has to get exactly 0.
I might have just put in like L minus R equals to 0 or.
What is the calculator just loading, like taking a long time to calculate it?
It's taking a long time to calculate. It's like the number, the LR is changing each time, but it's not getting to 0 yet.
It'll get there. Just keep pressing equals. Is it still doing it?
Yeah.
That's alright. I would put it in my calculator as well, but my wife unfortunately cleaned the room. Don't know where my calculator is. This calculator on my laptop is like too powerful. You know, it just gets it too quick.
Yeah. So when you said equals, did you mean shift solve or did you mean just equals?
So when I put this in, so let's say shift solve, my initial value is going to be 9999. So you press equals. So you see how, is that what you get, like continue, you press equals again?
Yeah, I just kept on pressing equals and it's just taking like years to get to it.
And is it still blank, or every once in a while it comes up saying this continue thing?
Yeah, every once in a while it comes up saying the continue thing.
Yeah, so you just keep pressing equals. Eventually it'll get there.
Yeah.
There is the manual way to do it. So, and your L minus R, it'll be something like that, times 10 to the minus 70. So basically a tiny, tiny little number, very, very close to 0.
Yeah.
Oh, maybe, I don't know, maybe it's kind of going back and forth based on the initial value. We can do it manually. Yeah, because it was closer. It was 80. So there's 88. But does it get further away? Oh, maybe depending on your initial value, maybe it just doesn't catch it. All right, we'll do it manually. When x is the power, how do you solve this manually?
So um, I literally don't know what to do. I don't think.
So if the power was squared, you would, or cubed or something, you would like square root both sides. If you have to make the power the subject, you log both sides.
Right. So do I do log 3 to the power of x
Mm-hmm.
and O equals to 2 to the power of x plus 1?
Log 2 to
Oh,
the
look.
x. Yeah.
And then do I then need to put them like to the front of each other?
Mm-hmm.
Yeah, so and then x log 3 is equals to x plus 1 log 2.
Mm-hmm.
And then do I need to do something like
Expand the bracket.
would that be x log 2 plus log 2?
Mm-hmm. Combine the x's.
So do I then do x log 3 divided by x log 2 is equals to log 2?
This is not times x log 2, it is plus x log 2.
So is it minus?
Yeah.
And then would the calculator give me a nice answer from here or probably not?
Probably, but how would you go from having two x's to just one?
Would this be, is this like x log 2? Oh, is this x log and then like 3 over 2? Or
Yeah, you would factorize out the x, and so it would be log 3 minus log 2, and like you just said, x log 3 over 2, and that is equal to log 2. And so what is x equal to?
is equals to log 2 over log 3 over 2?
Yeah, and I'll just write it as log 2 divided by log 3 over 2, so we don't have a fraction of a fraction. So put that in your calculator. 4 decimal places do you want?
So okay, so I got 1.71. Wait, how many decimal places? 4, sorry. So I got 1.7095.
1.7095. And I should have saved. Let me go back to my calculator. Shift solve. I went with lucky 7, and lucky 7 got me an answer. So it just depends on your initial value. You can get lucky. There we go. And they did something similar. Any questions there?
Yeah.
So, take logs of both sides is the big idea. We did that. Oh, hang on. Did I accidentally? So yes. So then exam question. We did those. So let's do question 5. Let's put it there. So I'll let you pick. Which one are we starting with? A, B, or C?
Just start off with it, I think.
Okay. I'm just gonna turn my light on. 1 sec. How do we do this one? Say it again, sorry.
Can I add log to each side?
Take logs of both sides, yeah.
And then move the x's, like x onto the front.
Mm-hmm.
And then expand the brackets for log 2x plus 1.
Mm-hmm.
X log 2 plus log 2. And then I would do x log 5 minus x log 2 equals log 2. And then I take out the x, which will be, I factorize the x and get x log 5 minus log 2 is equal to 2. And then would that then be x log 5 over 2 equals to log 2?
Mm-hmm.
And then I can just do x is equals to log 2 divided by log 5 over 2.
Mm-hmm.
And so x will be equals to 0.7565.
565. And let's skip to C.
And then for C, it will be 7x plus 1. So yeah, take logs of both sides, and then move the x's to the front. So it will be x plus 1 log 7 is equals to x plus 2 log 3.
Yeah.
And then expand the brackets for both sides.
Mm-hmm.
So log 7 plus log 7 is equals to x log 3 plus 2 log 3. And then I'll get the x's on one side and like the numbers on the other, so it will be x log 7 minus x log 3 is equals to 2 log 3 minus log 7.
Mm-hmm.
And then factorize the x's, so it'll be x log 7 minus log 3, which will be, and then do so and then make it so that it's x log 7 over 3 is equals to 2 log 3 minus log 7. And then could I just do that x is equals to 2 log 3 minus log 7 divided by log 7 over 3?
Yes. How would you divide by log 7 over 3 though?
So would you first get the answer from 2 log 3 minus log 7 and then divide it after?
So that would work, yeah. Or put the whole thing in the bracket, whichever.
So I got x is equals to 0.2966.
Looks good to me. And that goes there. 1 sec. So the answer was back here, was it? Oh, I just moved it around. I'm not sure where I put the answer. Oh well. I'm sure it is correct. And you've done it for the harder one as well. So any questions about those? I'll just see if lucky 7 is lucky here. Yeah, so for this type of question, just take logs of both sides, and that's why I use it for everything. Because it'll work for everything instead of the stuff. Lucky 7. There we go. That gets it as well. But I'm not sure if my laptop is getting that fast because it's just got the power for it. Because it's, emulating. So let's see. We did that one. That's hidden quadratic. So we did that. If we were to do 7b without a calculator, any idea what that would be? What would be step 1?
Step 1 be, so wait, can I just do, would I have to take logs of both sides again?
You would do that for part A. Part B already have a log.
Could you just do 5 minus x is equal to 0.8 over log 7? Or
it doesn't work that way. How does it work to convert a log into an exponential?
Oh wait, so it would be 5 minus x is equals to 7 to the power of 0.8.
Yeah. And so what would x be equal to? How would you?
X would be equals to 5 minus 7 to the power of 0.8.
Yep. And then you just put that in the calculator and get the answer. That's grand. Let's see. Solve this equation.
Okay.
Let me think about this. That's a bit weird. Minus. It's the same thing, I think. Just want to see. That's minus 2 log minus 2. Yes, we get an error. Okay, so how do we do this one? They tell me to use a graph first. There must be a reason for that. I'll delete this one. So minus 2 to the power of x.
Can you just make minus 2 positive and just do like 2x to the power of x is equals to 13?
Okay. So minus 2 to the power of x is equal to minus 13. And so what would you do?
Oh no, sorry. I would just do shift solve, and it gives me 3.7.
I think that's right. You could just make it positive 2. So 2 to the x is equal to 13. And I think you'd probably go about it that way. 3.70?
Yeah.
Yeah, grand. Let's see, this one. That's similar. They let you be the dummy variable and then yourselves actually help you out. Okay. Okay, solving log equations.
Yeah, I think that's it.
That's great. I'm happy with that because those are real difficult. Okay, working with natural logs. We saw E. Natural, so French phrase logarithm natural is French for natural logarithm. You know how logs always have a base, like base 10 or whatever?
Yeah.
So log base E, that's just called ln. L-O-N.
Okay.
And it is the opposite. Okay, so how would you do question A? They want an exact answer, and so calculator will give you a approximate answer, so we can't use that.
So I can't put that into my calculator.
So we could to check our answer. How could you solve it without a calculator?
I just do log E and 5 equals to x.
So you could take logs of both sides. So log e to the x is equal to log 5.
Yeah. And then, and that's just going to be ln x, isn't it?
Yes. And so the way you do it is you do so you bring x to the front and you've got log e. But you'd have to choose some log, and so you would choose log to base e, which is the same as ln.
Yeah.
And there's a reason for that. If you did put in your calculator, so next to your log you have ln. If you do ln and you do e, the ln of e, and I'll do it to the power of 1 just so it's just e. Ln e is 1.
Okay.
And so this is x times ln e. What is that?
Ln 5.
And what is ln e?
Log E of E. Is that just going to be log 5?
What I'm driving at is basically it's like the same as x times 1. So it's just x, yeah. So the answer is just ln 5. So that's kind of where it comes from. In general, if you have to solve a log or an exponential question with e, instead of taking logs of both sides, you would take ln of both sides, which is just a fancy name for log base e.
Okay.
So before we move on from that, I suppose, let me just see exam question. They get tricky. Okay, let's try question A.
Okay. So make it so it's log E on both sides.
Log E. So yeah, and I would just call it ln.
Okay. So ln E of 2x plus 2
Yeah, so ln E 2x plus 3.
equals 7.
Yeah.
And then do I need to do ln E to the power of ln 7 is equals, oh no, Uh, I'm a bit confused, I think.
Ln is just another name for a logarithm. So log rules. What do you do with the power?
Will it be like ln e of 2x plus... Oh, no. So it'll be 2x plus 3 goes to the front.
Yeah.
Equals to ln 7. And then would you do ln of e... ln 7 divided by ln of e.
What is ln e? I put it in my calculator.
1.
Yep. And so it's 2x plus 3 times by 1.
So is it just 2x plus 3 is equals to ln 7?
Yeah.
And then I just need to do x is equals to ln 7 over ln 7 minus 3 over 2.
Yes. For the sake of clarity, instead of writing ln 7 minus 3, I write it as minus 3 plus ln 7.
Yeah.
Because it's like square root. People will accidentally write ln 4. Ln 7 minus 3, oh, that's ln 4. When actually, no. It's not.
Yeah.
It's not in there with it. So x is equal to that. Or I suppose you could also write that as minus 3 over 2 plus a half ln 7 if you just wanted to be extra careful. But yes, that's the idea. A half ln 7 minus 3 over 2. So I wrote it the other way around. Minus 3 over 2 plus a half ln 7. Yes, it's an e. So you're taking ln. And ln is just fancy name for a logarithm. Normal log rules apply. And you can see there, ln e to the power of something is just going to be the same as that power because you bring it to the front times by 1. Any questions about that?
So I don't actually have to like work out the actual like ending bit where we get to like minus 3 plus ln 7 over 2. I don't actually have to like put that into my calculator.
It depends. So they wanted exact form. So they wanted it like this. If they wanted like the 4 decimal places, then you'd put it into your calculator.
Yeah.
But if they wanted it to 4 decimal places, what I would have done is right from the very start, I would have put it into the calculator. So you can do a bunch of stuff, then put it in the calculator at the end, or you can put it in the calculator from the very start. So this is what it is. This isn't an exact answer though. This is an approximate answer. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9. So to 9 decimal places. So it's pretty close, but it's not like if I needed it to 20 decimal places, you know. And you can put into your calculator minus 3 over 2 plus a half ln 7, and we get the same number.
Yeah.
So we can use it to check. Any other questions there?
No.
Okay, so exact form is how they prevent you from using just a calculator. Let us do part C. What do you think?
So okay, so I need to make each side have ln. So will it be ln x?
No. What if I did this?
Right, this is what we can do. Our little a is equals to that thing.
Yes, well done.
So if I just say that a is equals to e of x. And then, so e squared. And so the final thing would be like a squared plus 5a minus 14 equals to 0.
Mm-hmm.
And then uh, so a will be equals to 2 or minus 7. And so if you put that into the e of things, so will it be 2 is equals to e of x or minus 7 is equals to e of x?
E to the x.
Sorry. And then do I just put this into my calculator? Oh no, that's the final answer, isn't it? Or
Exact answer.
so do I now need to just put that into my calc, or would that not work?
That would give you an approximate answer.
Oh, will it be?
So just solve the two separately, manually.
Is this what I do at log?
Yeah.
So log 2 is equals to log e of x.
And what is what base would you use for the log?
Oh, sorry, for which one?
For both of them. So you have to put something into your calculator like log to base something. Which base would you use?
1.
That would be true for any other number. There's a very special number and it's e. So that would give us an approximate answer if we did that. There is a way to get an exact answer, and it's to use log to base e. Do you remember what's a special name for log to base e?
Ln.
Yeah.
So would it be ln 2 is equals to ln ex?
Yes.
Is equals to ln ex, and then do I need to do do I just put x to the front, don't I?
Yeah.
So it would be x ln e is equals to ln 2.
Mm-hmm.
And then would it be x is equals to I'm not able to do ln 2 minus ln e, or am I? Sorry. Or sorry, ln 2 divided by ln e.
And what is ln e?
Log e of x.
So ln e is log e to base e.
Log e to base e. Okay.
And what is any log to its own base? What is log a base a? It is 1. And that's why when we have e, we use ln.
Okay.
So ln e is the same as 1. And so x equals?
So x is equals to ln over 2. No, ln 2, sorry.
Ln 2. And how about this other equation?
Sorry, which one?
So we said e to the x is equal to 2 or e to the x equals minus 7.
So does that just mean that would it end up being x is equals to ln minus 7?
Well done. Ln minus 7. However, I suspect if I put into my calculator ln minus 7, ln is just a log, and you can't have a negative log.
So x therefore must be ln 2.
Yeah, and so I reject negative answer. So x is equal to ln 2. Any questions there?
No.
So that was just that quadratic thing. I just want to see. Sure. Sure. There now. Let me. What was the tricky? I think you got it. So, yeah, you take ln of both sides. So e to the x is equal to 2. So x is ln 2. E to the x is equal to minus 7. So x is ln 7. And we had to reject that. And so it's just using logs in reverse. Let me just see quickly. That stuff. Yes, take logs of both sides. And then for this one, it was e, so we're taking ln of both sides. Yeah, how did you find that stuff, Andrey?
I think it's like tricky, but like I think you just need to like get to know the log rules, and it'll probably be alright after.
Yeah, and I think I won't. I think we need to do the second half of that stuff particularly. Maybe I shouldn't have started it because we start in the middle of it. But anyway, yes, you're doing great, Andrey. Anything in particular you want to do next time? We can continue this.
Yeah, probably just continue this thing.
Okay. Any questions for me in general?